All right, welcome to another episode of Statistics with Mr. Robeson. Today we're going to look at IQR, which is interquartile range, and outliers. So we'll finally have a way to calculate outliers. We'll look at comparing box plots, interpreting box plots, and then we'll look at the differences between some box plots, histograms, and shape. All right, so IQR or interquartile range. All right, so we have to be able to calculate this IQR before we can calculate outliers. It's the only method we have. So the interquartile range is how long is the box. All right, so remember when we make our box plot, we've got a box from Q1 to Q3. Somewhere in here we've got the median. It does not have to be smack dab in the middle. It's where half the data values are below, half the data values are above. And then we have a line out to our minimum and a line up to our maximum. Maybe it looks like that. But the IQR is the distance from here to here. That is our interquartile range. It's that distance. All right, it's not this space, but it's this distance. It's the range of the middle 50% of the data. There's another way of saying it. Remember, range is the biggest minus the smallest. Well, the middle 50% goes from Q1 to Q3. So the range of that would be Q3 minus Q1. This is another measure of spread. So if you want to talk about measure of spread when you're doing your cussing, you can say the IQR is whatever the IQR is. All right, and you don't have to bring up standard deviation. You don't have to bring up range. You can just say IQR. That works. All right, so the rule for finding outliers, it's called the 1.5 IQR rule. That is its name. 1.5 meaning 1.5. IQR means we're going to do times the IQR. All right, so what we do is 1.5 times the IQR. We add that to Q3. So we take Q3 and we add 1.5 times the IQR. We're going to get some sort of value. Anything past that is what I like to call outlier land. All right, so anything up here past 1.5 times the IQR added to Q3 or up from Q3 is outlier land. All right, we do the same thing going backwards as well. So we start at Q1 and we go down 1.5 times the IQR. And anything below that is also outlier land. So anything down there, so we could have bottom end outliers or we could have top end outliers. All right, so let's take a look at an example here. So Mr. Robeson drove to work. It takes me a certain amount of time in minutes. Some days there's more traffic than others. Some days I leave earlier and there's less traffic. All right, but this is what we ended up getting. So my median here is 26. My Q1 is 24 minutes. Q3 is 28 minutes. All right, so now to find the outlier, so this is a graph of it. So this box plot definitely has an outlier. It's way up here, that 55. All right, but to calculate that for sure, what we do is we find our IQR. So that'd be Q3 is 28 minus Q1, which is 24, which gives us 4. And then we do, to get our top one, Q3 plus 1.5 times the IQR. So Q3 is 28 plus 1.5 times 4. 1.5 times 4 is 6. 28 plus 6 is 34. So anything above 34, which is right around there, would be an outlier. All right. We can also check for our low end outliers. Q1 minus 1.5 times the IQR would be 24 minus, so we're subtracting now, 1.5 times 4, so another 6, would be 18. So anything below 18 would be an outlier. Luckily 18 is down here, so there's no outliers down there. All right, so when we make our box plot, sure, we got 24 here, we've got 26 in the middle, we've got 28 here. All right, this line stops at 30. It's the highest data value we have that's not an outlier, so it stops there. And then our next dot is that 55 up here. We just put a dot, and that is an outlier. All right, we can do this on our calculator, but I'll go over calculator stuff on another presentation. But we can do this on our calculator, and it'll give us that dot. All right, and this line goes down here to 20. No problems down at the bottom end. So that's how we calculate outliers. All right, comparing box plots. So compare the number of home runs hit each season by Barry Bonds, and I switched this. It's no longer Babe Ruth, sorry. Hank Aaron. Hammer and Hank. All right, we got 5 number summaries and box plots. I did those on the calculator. So here it is done for us on the calculator. So if we want to compare them, that means we're going to cuss. All right, so for centers, all right, we don't have the means, but we have the medians. So this up top was Barry Bonds. So this is Bonds. And this is Aaron down here. So which one of them has a higher median value? So we can tell that by the box plots. It looks like the one down here with Aaron. So Aaron has a higher median number of home runs. All right, I didn't calculate that median. We could if we wanted to, but that looks like a lot of work. I can just look at the graph and say, look, this line is farther up than this line. All right, I don't even have my axis labeled, so it's like really not easy to tell, but this one's definitely higher than that one. If I had my calculator, I could just trace and it would give me that. Unusual next. Neither one of them has outliers, so we'll just say nothing unusual. All right, shape. All right, so Bonds has this one side that sticks out a whole bunch towards the right here. And Aaron has this one side that sticks out a whole lot towards the left here. All right, so ordinarily with box plots, we generally don't have to say anything about shape. But if we want to say that it looks like Bonds is skewed right and Hank Aaron is skewed left, that's okay. We can't always tell. It's not always obvious with box plots. So sometimes we will just skip that with box plots. All right, but they do each have one side that sticks out a little bit farther than the others. So this is even bigger than this side over here. So this side being bigger and this being bigger means it looks like we're being skewed down here. The right side here is bigger and this section here is bigger. It looks like Bonds is being skewed up towards the higher end. All right, and finally our other S, I'll go over here with it, our spread. All right, so there's a couple different ways we can measure spread now. So we've mentioned range a couple times. We can also use IQR. So the box for Bonds is farther out than the box for Aaron's on both sides. So that means his IQR, this length here from here to here, is going to be longer than Aaron's IQR from there to there. All right. Bonds also has a larger range, all right, because his goes much up higher here, and they're almost the same here. So we could just say Bonds has a larger IQR than Aaron and has a larger range. So either one of those by itself would be fine, IQR or range. IQR is a better measure of spread than range is, though. Like usually standard deviation is the best, IQR is probably the second best that we've gone over so far, and then range would be the third best. All right, so some interpreting of box and whisker plots or box plots. So this is the amount of sleep each night for a high school student was tracked for 6 months. The data was then organized in box plots below. So this is a box plot of the number of hours of sleep this person got on each of the Monday nights, each of the Tuesday nights, Wednesday nights, Thursday nights, and so on. For what nights was 7 hours in the middle 50% of the data. So remember, the middle 50% is from Q1 to Q3. So we want 7 to be between. So 7 looks like right there. So let's see. It's that one's got it. That one's got it. Nope. Nope. Oh, that looks close, but I'm going to call that a nope. And that one, yes. So it looks like Monday, Tuesday, and Sunday are our winners for that. What night has the highest median sleep time? So we're looking for the highest median. So the median is the middle line. So like here would be the median, here, 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 up here, here, and here. So the highest median looks like it's going to be that guy up there, which is Friday. All right, so it looks like we're getting the most sleep on Friday nights. Do you think that night also has the highest mean? All right, so Ordinarily, we'd just say, yeah, sure. But this guy throws things into doubt. It looks like we have one night that had like 0 hours of sleep on a Friday night. All right, so maybe Friday's to the highest, or maybe Saturday's the highest. So maybe Friday or Saturday has the most, has the greatest mean. All right. Which night has the largest IQR? All right, well, now we're looking for the largest distance from here to here. That is our IQR for each one, distance from there to there. So this one's bigger than that, and that, and that. This one looks about the same size. This one looks to be bigger than all those, and this one's back smaller. So the one with the largest IQR, which would have the largest measure of spread, would be Saturday, it looks like. So Saturday looks like it has the largest IQR, so we could say that has the largest spread. Confirm that Sunday has an outlier. All right, so here's Sunday. First, we need to find what is Sunday's IQR. So this looks like it's maybe 8. This looks like it's maybe 6. Again, I'm just estimating. All right, so that means the IQR for Sunday is roughly 8 minus 6 or 2. Like if we want to say it's 2.5 or something a little bit bigger, that's fine. We can do that. All right, because we're not sure based on the graph here. But now the outlier is on the top. So the outlier is up here. So we want to see what's 1.5 times this IQR. So we want to do 8 plus 1.5 times 2. Well, 1.5 times 2 is 3. So we get 11. So anything above 11, which I think is right there, is outlier land. So it is, in fact, this dot looks like it's up at 12, so that is an outlier. So we say 11 is less than 12, so 12 is an outlier. All right, I just like this graph. I just think it's cool. So here's statistics being used for political science and history. So a lot of history professors were asked to rank presidents. All right, so like this guy, whoever 16 was, looks like he's got a lot of number ones, and his highest ranking was like 2 or 3. All right, this guy, the guy before him, number 15, he's got a bunch of really high rankings, like 40th and 41st and like 38 and 39s. All right, and this was done, I think, let's see, we only had 44 at this point, so this was done during Obama's administration, probably towards the middle, because I've been using this graph for a while. If you're curious, this is Lincoln. All right, this is FDR, Franklin Roosevelt. All right, here's Washington. All right, so it looks like consistently those guys have been ranked as some of the best presidents. Here's Jefferson doing pretty well. 26 is Teddy Roosevelt. He's also doing pretty well. And yeah, I like how it's also, you can have the political parties, like red is a Republican, blue is a Democrat, and then the grays are all the other different political parties. So we can compare all the presidential rankings by party and by other things. We can see all these outliers, like some professors rated very differently than other professors. All sorts of interesting things happened here. I just like this. It's fun to play with. All right, so how do graphs below compare to each other? So we've got the box plot here. All right, this is called notched. They put a little notch where the median is. It's not really anything different. Instead of just a straight line up and down, they make a little notch. All right, looks like it's got a couple outliers on the ends there. This is a histogram. So like this is the number of 39s and 41s and whatever. All right, and it looks this shape. And this is taking that same histogram and kind of smoothing it out. It's called a density plot. We'll deal with this more later when we have normal data. All right, so the thing is, all three of these graphs represent the same data. So as you can see, I tried to line these two up as best I could, but like this section from here to here is basically the data from, I could probably use a different color because you can't see that. I'll go back to green, and we'll go back a slide. It's basically the data from a little bit above 80, which looks like there. It's tough to draw straight lines on here. And closer to 120, maybe there. That one's turned out pretty straight. All right, so most of the data, 50% of the data looks like it's in there. And then there's 25% up here and 25% down there. All right, and we can tell that from this here and here. All right, with this other guy here, now we get the same thing going on. And I really want you to take a look at this box plot, because this box plot is interesting. We almost have no space here. In fact, we don't have to have space here. Like Q1 and Q2, the median could be the same number. It happens. And then Q3 is right here. There's the end of outlier land. So everything from here on out would be considered outlier land. So we have tons and tons and tons of outliers. So outliers does not have to be just one data value. It can be lots of data values, especially if we have lots of data values that are clumped together, like all the data values we have in here. That's most of our data right there. All right, that's 50% of our data is in here. All right, and then there's another 25% right there. So that's 75%. And then we've got all these outliers up here, far, far away. All right, and you can see it's heavily skewed to the right. All right, it's got a tail way over going this way. Same with this one. You can see big tail here, and all these outliers up here were skewing off to the right. All right, so now we know how to calculate outliers using our 1.5 IQR. So IQR times 1.5, and it's added to Q3, or Q1 minus 1.5 times the IQR. All right, we can compare box plots like we did with Hank Aaron and Barry Bonds. We can interpret box plots like we did with the Knights of Sleep and the Presidents. And we looked how box plots, histograms, and shape compare. All right, so there's a Sporkle quiz to go with this. I'll post in the links and post on Google Classroom, and there's going to be homework on Google Classroom. So get working on that. It will be due next class. And there'll probably be another video before next class too. So stay tuned. Bye.